Hey guys, this will be the progress check C for Unit 5, just going over the questions there. There's 6 of them. So starting with the first one, hopefully you're reading along. So for the first one, there we go. So for the first one, it says the second derivative of the function f is given by f double prime of x is equal to x squared cosine of the square root of x minus 2x times by cosine of the square root of x plus cosine of the square root of x. So I have the first derivative. Okay. I would say I should factor out the cosine of the square root of x. I'm wondering if that would really matter because this is a calculator required, so I don't know if it would really matter much because I'm going to plug it in, but it might just be easier. So if I take out the cosine of the square root of x, I'd be left with x squared minus 2x plus 1. And then this will be, so I'm trying to find points of inflections, which means I want to know whenever this is going to be equal to 0 and whenever f double prime is going to change from positive to negative or negative to positive here. We're on the interval from 0 to 3. So, I mean, I can graph this right here and, yeah, we'll just graph it. So, so go to y equals, it was cosine of the square root of x, and then we had x squared, and we had, let me take a look, go back here, x squared minus 2x plus 1, was it? Plus 1? Plus 1. On the interval from 0 to 3, graph that. Oh my gosh. Let me go back to my window. We're going to make that y scale a lot smaller. Let's do like -5 and 5. That might not even... we can definitely do better than that. Oh my gosh, I hate it when this is such a bad app, not gonna lie. Alright, let's change that to like -2 and 2. That's better, I guess. So we're looking at when it has inflection points. Now, I don't believe that right at x equals what appears to be kind of 1, you can see that it just touches. And you know why it just touches? Because whenever I factor this right here, this becomes x minus 1 and x minus 1. And so it's just going to touch right there because that's a duplicate. That's a multiplicity of 2. So it's just going to touch right there, which means that I don't actually change concavity. You can see that the second derivative is positive to the left, and it's still positive to the right, and 0 in between. And so that means it's still concave up. But then at this one right here, that's changing concavity right there, which means there's an inflection point. So let's go here, go to 2, and then we're going to do enter, and we get 2.467 only, and that's going to be A. So x equals 2.467, and that's going to be A. Okay, on to 2. Another calculator required. So we have the second derivative of the function f is given by, so we've got f double prime of x, and that's going to be equal to e to the sine of x, and then we're going to have 2 cosine of x minus x sine of x plus x cosine squared of x. Okay, the function f has many critical points, 2 of which are at x equals 2.074 and x equals 7.980. So these are, it says that there are many critical points, but here are two of them. And which of the following statements is true? Local minimum and local maximum, when I'm looking at the answers, that's what I'm seeing. So I am going to assume that we're going to be using the second derivative test. So these are critical points. So plug these critical points into the function, and if you get a positive number, that means it's concave up, and that would make it a minimum. And if it's a negative, it's concave down, which would make these critical points negative. Okay, so I'll be honest, I'm gonna make you guys do it, and I'm not gonna do it. Okay, so yeah, go ahead and plug these values in, and yeah, try that out. For 3, we've got a graph, the graph of f prime. The graph of f prime, the derivative of f, is shown on which of the following open intervals is the graph of f concave down. So concave down, concave down is going to mean that the f double prime of x is less than 0. So looking at the graph, it's kind of, I'll try and graph it the best that I can here, but it goes up and it goes down, touches the x-axis, goes up a little bit higher than that before, and then kind of goes like that. And this right here is at -3. This maximum right there is at -2. This is at 0. This point is at 2. And then it's like 3 right here. And then it's like 4 right here. And so this is the graph of f prime, though. Keep that in mind. That's the graph of f prime of x. And we want to know when f double prime is going to be negative. So that's going to be when the slope of this graph is negative. So I can see the slope is negative here and here. That's where, this is where f double prime is going to be less than 0. Because that's where the slope of f prime is negative. And so that's going to, yeah, so the intervals are going to be from -2 to 0 and 2 to 4. So that's going to be A. All right. Let's go to 4. So for 4, we have another graph of f prime. Let f be the function defined by f of x equals, okay, so we have a function. The graph of f prime, the derivative of f, is shown above. On which of the following intervals is the graph of f concave up? So concave up, that's going to be when f double prime of x is greater than 0. And if we're looking at the graph, I'll try my best to draw what the graph kind of looks like. Then it goes up, and it kind of goes more like this right here. Then it goes back up. So this is the graph of f prime of x. This value right here is at -1, and then this right here is 0, and then I think here it's like at 2. And since this is the graph of f prime, we're trying to see when f double prime is greater than 0. So that's when the slope of this graph is positive. So I can see it's positive here. And it's going to be positive here. So that's going to be between -1 and 0. And when 2 is greater than, when we're greater than 2. So that's going to be B. All right, let's go to 5. The second derivative test cannot be used to conclude that x equals 1 is the location of a relative minimum or relative maximum for which of the following functions? Oh no. That's a lot to look at. Okay, let's just grab A and run with it. See what we get. So we have, oh my gosh, f of x is equal to cosine of x squared minus 1, where f prime of x is equal to that, and f double prime, okay. So at x equals 1, we'd first have to prove that that's a critical point. So we have f prime. Let's find f prime of 1. F prime of 1 in this case would be negative 2 times by 1 times by sine of 1 squared minus 1. So that's going to be equal to negative 2. And then that's going to be equal to sine of 0. And that's going to be all 0. So it is a critical point. And then we need to see f double prime of 1. So f double prime of 1 would be negative 2 sine of, that's just going to be 0 whenever I plug that in. And then minus 4 times by 1 squared times by cosine of 0. So that's going to be equal to 0, because that's going to be 0. Cosine of 0 is 1, so it's going to be negative 4. And so this would mean, so this is a critical point, but the second derivative is negative, meaning concave down, and the critical point would therefore be a maximum. But it says the second derivative test cannot be used to conclude that x equals 1 is the location of a relative minimum or maximum. So this is not this is not the right answer, because it can be used. So let's try B. So we've got, f prime of 1. F prime of 1 is going to be 2 times by 0, and then e to the, it's not going to matter. It's all going to be 0. So that's going to be equal to 0. So it is a critical point. F double prime of 1 would be equal to 4 times by 0 squared. It doesn't really matter what this is. It's going to be e to the 0. That's still going to be 0. Plus 2 times by e to the 0 power. This is all going to be equal to 2. So the fact that I'm getting this as a positive or negative number means that I can use, that means x equals 1 is a minimum or a maximum. I'm getting numbers that are non-zero for that right there. So not B. Let's try C. Let's make sure f prime of 1 is equal to 0. So that's going to be 1 squared plus 2 minus 3, which is going to be equal to 3 minus 3, which is going to be 0. So that it is a critical point. Now f double prime of 1 is going to be equal to 2 times by 1 plus 2, which is going to be equal to 4. So not going to be this one, so it's going to have to be D. Let's go ahead and check. So f prime of 1 is going to be equal to 4 times by 1 cubed minus 12 times by 1 squared plus 12 times by 1 minus 4. So that's going to be equal to 4 minus 12 plus 12 minus 4. That's going to be equal to 0, so we're good. And then f double prime of 1 is going to be equal to 12 times by 1 squared minus 24 times by 1 plus 12, which is going to be equal to 24 minus 24, which is going to be equal to 0. And because the second derivative is 0, it's inconclusive, because it's just inconclusive. So yeah, there we go. It's D. Okay, and then one last question, question 6. So for 6, we have the graph of f double prime. The second derivative of the continuous function f is shown on the interval from 0 to pi halves. On the interval, f has only one critical point, which occurs at x equals pi 16th. Which of the following statements is true about the function of f on the interval from 0 to pi halves? So again, I'm going to try and do my best sketch that I have here, but it's just gonna look like this right here. This is 0. This end is pi halves, and this right here is pi 16ths. Okay, so the graph of f double prime, the second derivative of the continuous function f, is shown on the interval. On this interval, f has only one critical point. So, and this is at x equals pi 16th. So this right here is a critical point. Make sure that we understand that this graph is f double prime of x, but this is a critical point, meaning that f prime of x is equal to 0. Right? F has only one critical point, which occurs at x equals pi 16th. Okay? Which of the following statements is true about the function f on the interval? So let's read A. A, f has a relative minimum at x equals pi over 16th, but not an absolute minimum. Pi has a relative minimum. Let's think about this. F has a relative minimum, but not an absolute minimum. That could be true or it could be false, I think. So, if it were an absolute minimum, I'm going to come back to that one. Let's go to B. The absolute minimum of f is at x equals pi 16th. Okay. Maybe I need to think about this more just in terms of this second derivative test, since this is what it should be testing on. Relative, absolute. So I think we've got to think about two things. And as I look at these questions, it's asking about relative minima, and it's also asking about absolute. So relative refers to the first or second derivative test. Absolute refers to the candidates test. Right? Okay. Or maybe we're using both. But so the absolute minimum of f is at x equals, okay. Let's also think about this right here. So this is f double prime, right? So f double prime is positive here. So we can say that f double prime of pi 16th is greater than 0, which means f is concave up. Just gonna try and gather some clues about f. F is concave up, and we know that this is a critical point. So this means that f of pi 16ths is a minimum. It is a minimum because we have it's concave up, and this is a critical point. Now, is it a relative or is it an absolute? So we would have to think about the endpoints here as well. Okay, so the candidates test says that absolute extreme values will occur at the endpoints or at the critical points. So can we rule out that these are not that at these values right here, it's not going to be absolute or something like that, right? Okay. So it definitely is a relative minimum. Okay, let me read C. So f has a relative maximum at x equals pi 16th, but not an absolute maximum. Okay. It's not going to be C because it's not going to be a maximum, and it's not going to be D. So it's either A or B. So it's either just, we got to rule out whether or not it's an absolute minimum or not. Okay. The thing that makes me feel like that it should be B is that this looks like it's a sine wave, right? Or a cosine wave, or it's some sort of trigonomic wave like that right there. Meaning that at this point right here, it's gonna, if you think about the sine and cosine wave, right? The sine and cosine waves, they're cyclical. And so at these points right here, there are always going to be relative minimums or maximums, right? And then also you'd have to consider these points right here. So because this right here is an inflection point, meaning at inflection points, the second derivatives are, or you can think, not a second derivative, but slopes are at its greatest right here. And so that's where I'm thinking about zeros, greatest, and zeros right here. These are all going to be cyclical, meaning that depending on the derivatives, they're going to be maximums or minimums, if that makes sense. And so I don't think we're going to, since this is not an these are not inflection points, they're not going to be mins and maximums of any sort of derivatives of f at all. And so that makes me think that this right here, because it is a minimum, at f, it would also have to be an absolute minimum. So basically what I'm saying here, if I had the graph of f and I plugged these values into the graph of f, there's not going to be a chance that it's going to be minimums or maximums. That has to occur at pi 16th. And so, yeah. Yeah. Okay, I'm going to say that it's B. I'm going to say that it's B. Sorry, that took me a lot of thinking. I don't even know if you guys followed me here. But if you didn't, maybe just ask me in class and maybe I can explain it in more detail. I think I have a better understanding of this question now, but yeah, I think it's got to be B. We've already ruled out that it's not going to be C or D because it's not a maximum because of this right here, and just thinking about whether or not these can be considered maximums absolute or if it's going to be here. So if that didn't make sense, just ask me in class and maybe I can explain it just a little bit better than that. But okay, and that should be everything for this video.